Hey everyone and welcome to Toppscholars. In this session, we are going to discuss about indefinite integral. First of all, make sure that you know all the formulae for your differentiation and you have also studied about application of differentiation. Also check out those videos. We have already uploaded that. Apart from that, in this session, we are going to talk about indefinite integral. We'll see all the formulae. This is a one-shot video basically based on NCERT. So let's begin. Now, indefinite integrals. Now, what is the use of integration basically? As we already know, we have studied about the basic of integration, right? That is to find out the area under the curve. So here, what do we have? We have the x-axis, we have the y-axis, and then we are supposed to find out this area, right? So to find out this area, we use integration. Now see, whenever we don't have figures like squares or rectangles, it becomes very difficult to find out the area, right? So if a figure is like this, it's not a regular figure, right? So to find out the area of such figures, what we do is we break it down into smaller rectangles and then add them. Basically, that is the idea in integration. Okay. So here also we do the same thing. What we actually do is we break it down into small pieces of rectangles. You can see rectangles form here, right? And then when I say small, that means very small, right? So we learned in the previous classes by adding boxes, right, to find the area of the particular image. But that does not give you the accurate value, right? So here what we do is we try smaller boxes, but this is also not accurate as I just mentioned. Okay. So what we do is we divide them into very smaller parts, right? We divide them into very smaller parts and then add them. Basically, we divide them into smaller rectangles only, whose width is basically dx, which is very small, right? Okay. So how do we represent? We represent integration as or by this symbol basically. This is the symbol by which we represent integration, right? So this is basically, this gives you the sum of some function, whatever function is that completely depends. Yes. So let us talk about integration now. We know that there are two types. One is the indefinite integration, which is represented like this. That is integration of fx or integration fx dx. And then we have definite integration. So when do we use definite integration? Obviously, we have a different chapter on that as well. And we use definite integration when we have the concept of limits applied there from where to where. So for example, from A to B, right? From A to B. So if you want to find out the sum only from A to B, particularly this, if this is A and this is B, and you want to find out the area under the curve from A to B, suppose, then you will apply definite integration, right? Let's continue. So integration is what? Indefinite integral is the integration of a function, which is the reverse process of differentiation. We already know this. This is reverse of differentiation. So f is a function, suppose, and its derivative is f dash. So f is a function, its derivative is f dash. Then we can say that the integration of f dash is f. That is reverse of it. So integration is the inverse process of differentiation. All this is basics. We should know the formulae, of course. And then once we know the formulae, we'll solve some of the problems based on it. So the process to find the primitive is known as integration, right? That is the process to find out the original function basically is called as integration. Integration is also called as antiderivative, antidifferentiation. Now understand. Now if I talk about the derivative of x square, I'm talking about the derivative of x square by 2. What is the derivative of x square by 2? The derivative of x square by 2 is x. How? Because derivative of x square is 2x. 2 will get cancelled and you will get x, isn't it? So differentiation and integration, as we know, are inverses. So here d by dx of x square by 2 is nothing but x. So adding or subtracting any constant with x square by 2 does not change the derivative. What does that mean? This means that, let us have a look at an example. See, here I am taking x square by 2. I am adding 1. What is the derivative of 1? The derivative of 1 is 0. So it doesn't matter. Still you are getting x. If I take 5, 10, 20, doesn't matter, right? Say I take one more constant here, x square by 2 minus log of 7. This is minus log 7. This is a constant. Still I'm going to get the value as x, value as in the derivative of x square minus log 7 as x. Here also I'm getting x, here I'm getting x, here I'm getting x, isn't it? So what can we say? We can say that when we integrate x, that is the integration of x, I can get this, I can get this, I can get this, I can get many more values, right? So how do I know what is the constant? I don't know what is the constant there, right? So in that case, this constant can be anything, correct? And that is why we need to take some constant c in that case. So to make this balanced, we add a constant c. How do we add that? Let us see. So we can say that the integral of x is nothing but x square by 2 plus c. Now this c can be anything. It can be minus log 7, it can be 1, it can be 0 also, it can be minus 10, minus 20, minus 4 by 5. Completely depends. So every time, whenever we find out the integration of a function, we are going to write down plus c at the end. Is that clear? This we do in indefinite integral. In definite integral, we don't do that because we already have the limits fixed, right? So that's the difference. Okay, let's continue. What is the meaning of this c? C is called as the constant of integration. We call c as the constant of integration, right? And this is the symbol for integration. This is the symbol for integration, right? So here we have d by dx of fx plus c is equal to fx, right? So we can say that f plus c denotes a family of antiderivatives, of f, obviously. So this is what is important, right? So if I say that d by dx of fx plus c is, say, capital Fx, then here if I integrate, right, so it will be reverse of it, that is fx plus c. Clear? Okay, let's continue. So this is the integration symbol. We already know this. This is integrand, right? Dx is the variable of integration. Now, this can be with respect to t, with respect to x, with respect to z. That completely depends on the question when we'll see that. Here, it is with respect to x, fx dx. That is integration of fx with respect to x. So, variable of integration is very important because if I take, suppose, 3z dx. Now, that 3z, z is not the variable because dx we have written. So, 3z dx, that 3z will be considered as a constant there. So that completely depends on this, which is some function gx plus c, right? C is the constant of integration. Okay. Now comes the actual part which we are going to study, and we are going to use that in the problems as well. So integration of x raised to n dx is nothing but x raised to n plus 1 by n plus 1, where n is not equal to minus 1, because if n is equal to minus 1, then definitely the denominator will become 0, and then we are not going to get the actual value, right? So for that we have a different formula. So constant coefficient rule, that if you have a constant multiplied by a function, you take the constant outside and then take the integration of the function, right? With respect to the variable. Sum and difference rule, this we have studied in derivatives also, same logic applies here. So if we have two different functions, fx plus gx, right? So integration of fx plus gx is nothing but integration fx plus the integral gx dx, right? You can separate that basically, find out separately. So for example, this can be sin x, this can be x cube. One is trigonometric function, second is polynomial function. Just separate it and subtract it. Take the integral separately, subtract it. And then 1 by x dx will be equal to log of mod of x plus c. Here also obviously, once you get the final answer, you'll add plus c there. Now a raised to x. Integration of a raised to x dx is a raised to x by log a, right? If you recollect the differentiation, it was a raised to x into log a. Because integration is reverse, that into becomes division, a raised to x by log a. Derivative of e raised to x is e raised to x. So here, integration of e raised to x is, it remains the same, e raised to x plus c, right? Now, let us talk about integration of sin x dx. What is derivative of sin x? Derivative of sin x is cos x. Here the sign changes. Integration of sin x is minus cos x. Integration of cos x is sin x plus c. Integration of sec square x is tan x, because derivative of tan x is sec square x. So integration of integration of sec square x is tan x plus c. Similarly, integration of derivative of cot x is minus cosec square x. So integration of cosec square x is minus cot x. So in this way, actually you don't need to remember any of these formulae. If you are thorough with your derivatives formulae, that is the formulae that we have studied in differentiation, you can easily find out the formulae for these, right? So nothing new in that. So this is the list. Please make a note of this. Now let us see some of the examples. We'll see some basic examples first, then we will move on to the advanced examples as well. So example number 1, find the integral of fx is equal to 2 sin x, right? So this is like your c into some function, right? 2 is a constant. We know 2 we can keep outside, and then we just have to take the integral of sin x. So let suppose I be integration of 2 sin x dx. So 2 will come outside, and this is what we are going to use. We'll write down this 2 outside here, and then integration sin x dx. Now what is integration of sin x? Cos x or minus cos x? So don't get confused in that. This is minus cos x, right? Because derivative of sin x is cos x. Derivative of cos x is minus sin x. So integration of sin x is minus cos x. So that's it. And then plus c. So minus 2 cos x plus c. So final answer you can write down minus 2 cos x plus c. I hope this part is clear to all of you. Simple question, basic question. There is nothing new in that. Let's continue. Example number 2. It says find the integral of fx is equal to 5 by x. So again you can keep 5 outside. You can just take 1 by x as you know. And then you know what is the formula for integration of 1 by x dx, right? So again constant 5 will come outside. Integration 1 by x dx. We know that derivative of log x is 1 by x. So integration of 1 by x will be log x plus c, right? Simple. Let's continue. Now we have integration of sec x by sec x minus tan x dx. Now understand this. This is an interesting question. Obviously, it is very simple. So we have sec x by sec x minus tan x. So whenever you get the combination of sec minus tan, always remember, whenever you get the combination of sec minus tan, you multiply it with the conjugate. Now what is the meaning of conjugate? If you have a minus b, you multiply by a plus b. Why do we do that? We do that because a minus b into a plus b becomes a square minus b square. And we know that sec square minus tan square is always 1. So to make the denominator 1 here, and also it will be helpful for us in the numerator. Let us see how. So we are multiplying sec minus tan with sec plus tan, right? So this denominator becomes sec square minus tan square. And this will become sec into sec is sec square x. Sec into tan is sec x tan x, right? Now this part denominator becomes 1. So what is left? Integration sec square x plus sec x tan x dx, right? So integration of sec square x is what? Tan x. Integration of sec x tan x. You can separate it now, right? That is sec x, right? See, I separated it. So this becomes tan x. This becomes sec x plus c. Simple, very simple and straightforward, nothing in that. Let's continue further. Okay, the question says write the antiderivative of. Same thing, write the integral of 3 root x plus 1 by root x, right? So let's move on to the solution. So let this be I, integration 3 root x plus 1 by root x dx. So again you can separate it, isn't it? Root x, can I write down root x as x raised to 1 by 2, right? And 1 by root x as 1 by x raised to 1 by 2. And 1 by x raised to 1 by 2 becomes x raised to minus 1 by 2, right? So see here, this is 3 root x plus x raised to minus 1 by 2, because once this goes in the numerator, the power will become negative, right? So here, this also can be written as x raised to 1 by 2, which is okay. We might do it in the next step. Okay, see here. Now, we can use what? X raised to n, right? Integration of x raised to n. What is that? X raised to n plus 1 by n plus 1, right? So use it here. It's very simple. So 3 times this becomes x raised to 1 by 2 plus 1. That is 3 by 2. And then here also minus 1 by 2 plus 1. Correct. So further if you solve this, this is going to give you, see if you observe this, 2 plus 1 is 3 by 2, and then 3 will get cancelled. So basically it's just solving the fractions. I know you can do that, and then you get the final answer here. That is 2 into x raised to 3 by 2. X raised to 3 by 2 can be written as x root x plus this can be written as 2 root x plus c. So this is your final answer, right? Simple. Let's continue. You can take that common if you want. Now evaluate cos inverse of sin x. Now generally whenever you get something like this, cos inverse of something or sin inverse of something or tan inverse of something, then try to make this cos, because cos inverse of cos, then you won't have that, and then you'll just get the angle whatever is left, right? So here sin x, but then how do you convert that? We know that sin x can be expressed as cos of pi by 2 minus theta or cos of pi by 2 minus x. Same thing, if the angle is x, we'll write it in x. So sin x is cos of pi by 2 minus x, which lies in the first quadrant. So cos inverse cos, don't have to actually cancel it, just for your understanding. So this becomes I is equal to pi by 2 minus x, right? So pi by 2 minus x. So this becomes, I mean, you can separate that, right? So integration pi by 2, which is a constant. See, pi by 2 goes outside, and then 1 dx minus x dx. So 1 dx. Integration of 1 is x, right? Derivative of x is 1. So integration of 1 is x. So pi by 2 x minus, this is x raised to 1. What is x raised to 1? We know that x raised to n is x raised to n plus 1 by n plus 1. So x raised to 1 will become x raised to 1 plus 1 by 1 plus 1. So that is going to give you pi by 2 x minus x square by 2 plus c, right? I hope this part is clear to all of you. Let's continue. Let's have a look at one more example. Write the antiderivative of 7 root x plus x raised to 7 by 2. See, again this is a similar question, isn't it? 7 root x plus x raised to 7 by 2. So here can we say root x can be written as x raised to 1 by 2, correct? Let us do that. This is root x. So this becomes x raised to 1 by 2, 7 goes outside, plus x raised to 7 by 2. Now, x raised to 1 by 2. Can we say it is x raised to 1 by 2 plus 1 by 1 by 2 plus 1? And here also we can have x raised to 7 by 2 plus 1 by 7 by 2 plus 1, right? You can solve that further. And then that gives you, see, after solving, this is what you get. This is basic math. You can obviously do that, I know. Okay, let's continue. Okay, we have a new example. It says e raised to 5 log x. E raised to 5 log x. Now, if you remember, 5 log x, a log x can be written as log of x raised to a. So here also 5 log x can be written as log of x raised to 5, right? So e raised to log of x raised to 5, isn't it? Now tell me one thing, e raised to log of something, e raised to log of some function is the function, that is e raised to log of fx is fx, we already know. So firstly, let me take it here, right? And then e raised to log, don't cancel, just for your understanding, only this part will be left, x raised to 5, that's it. And then we can use the formula for x raised to n, which is x raised to n plus 1 by n plus 1. So x raised to 6 by 6 plus c is the final answer. Simple. Let's continue. Now let us see the different methods of integration. This was just the basic where we directly used the formula and solved it, right? These were very simple questions. But sometimes you cannot solve them directly. So for that, you need to do some kind of substitution. So substitution method is one of the methods. Second method is integration using partial fractions. Third method is integration by parts. The fourth one, in partial fractions, obviously we'll have two types. So fine, we'll cover both the parts here. So let us talk about integration by substitution first. So in integration by substitution is a technique used where the integrand contains a composite function. The standard formula for substitution, f of g of x times g dash of x, which is nothing but the derivative of g of x dx. So if you get something like this is considered as f of u du. So we'll replace that. How we'll understand in the questions, don't worry. So we'll assume g of x as u, then we take the derivative, right? So we get g dash of x, that is this. So that becomes du. So this is u and this is du, right? So this gets converted. That is why we get f of u du. Now let us see some of the steps. The steps involved are, we identify the integral, it should be of this form. Basically what they're trying to say is, give a simple idea. If you see integration, if you see a function and if you see the derivative of that, there only, then in those cases you will apply substitution method. Like if you see sine also, if you see cos also, then you can apply this. If you see say x square and you also see 2x there, in that cases you can apply. So step 2 is you choose a new variable and you can take it as t, you can take it as u, that's your choice, whatever you are substituting it with. And then substitute the new variable into the function and the value of dx at the end, obviously. And then integrate the new function. That's it. Let us see how we are going to solve this. So first example is sine of 2x dx. Now this is sine of 2x dx. So what we can do is, we know the formula for sine of x. We don't know the formula for sine of 2x. So what we will do, we will replace 2x with some variable. It can be t, it can be u, that depends. So let us begin with the solution. So let u be 2x. Now if I differentiate both sides with respect to x, du by dx, derivative of 2x is 2. So du by dx is 2. If I take dx on the other side, du becomes 2 dx. Indirectly, dx becomes du by 2. Wherever you have dx, you put du by 2 now. Wherever you have 2x, you put u now. So see what you get. So integration sine 2x dx, 2x is u, dx is du by 2. So you get integration u du by 2. 2 is taken outside. Now you know the formula for sine u, right? Integration of sine u is minus cos u. So this becomes 1 by 2 minus cos u plus c, right? And then again you need to replace u with what? With 2x. So 1 by 2 cos 2x plus c, right? That's it. And that is your final answer. Simple? Okay. Let us see an example. So it has x cos x square dx. Now see this x square, you can take it as t or u or whatever you want. That's your choice. And once you take the derivative of that, its derivative is 2x. So x is already available. You can later multiply by 2, divide by 2. You can also replace it with dx later. So this is x square is equal to u. See, x square is u. So differentiating both sides with respect to x, du becomes 2x dx, right? So x dx becomes du by 2. Clear? Let us solve. So this becomes 1 by 2 cos u du. Integration of cos u is sin u. So this becomes 1 by 2 sin u plus c. Now what is u? U is nothing but x square. That's it. So put x square here and then you get 1 by 2 cos of x square plus c, and that is your final answer. Simple. Let's continue. Now let us see a new question. It says integration tan x dx. So we have integration tan x dx. Direct formula do we have? We don't have the direct formula. So tan x can be written as sin x by cos x dx. Now we'll take cos x as t. So let us take cos x as t or u. So du will become minus sin x dx, right? So solve this further. So that will become minus of integration of 1 by u du. Now integration of 1 by u is how much? Log u, isn't it? So minus ln of u plus c. That is minus log of cos x plus c. So minus log cos x. So can I say this is your final answer basically, right? Let's continue. Sec x dx, same thing. Sec x can be written as sec x multiplied by sec x plus tan x. Here also sec x plus tan x. Why are we doing that? So that we get sec square x and sec x tan x, for which we know the formula. So this becomes sec square x plus tan x sec x by sec x plus tan x, isn't it? Now, what we can do is we can consider this denominator as u. If this is u, what is the derivative of sec x? It is sec x tan x. What is the derivative of tan x? It is sec square x. So the entire numerator becomes du. So we get du by u, right? So du by u. Integration of 1 by u is log u. But what is u? U, as we know, is sec x plus tan x. So we get log of sec x plus tan x plus c. Simple. That's it. So this is how you solve. Similarly, we have x square into e raised to x cube. So x square into e raised to x cube. You can consider x cube as u. So let us do that. So if I take x cube as u, 3x square dx will be du. We already have x square. So can I say x square dx will be du by 3? So we get du by 3. Integration of e raised to u is e raised to u. So 1 by 3 e raised to u plus c. What is u? U is x cube. Put it here. So 1 by 3 e raised to x cube plus c. Clear? Simple. Let's continue. Now let us see one more example. We have sin cube x multiplied by cos square x dx, right? Now understand this question. Sin cube x, can I write down sin cube x as sin x into sin square x? Yes. And this is into cos square x dx. Now from here, sin square x can be written as 1 minus cos square x. So this becomes 1 minus cos square x into cos square x. Now cos square x can be multiplied inside. If you want to take that, you can do that. Or else you can put cos x as t. Okay, we are multiplying inside, no problem. Now let us take cos x as u. If we take cos x as u, then this is u square u raised to 4. Then minus sin x dx will become du. So sin x dx will become minus du. So this will become minus here. I hope you're understanding this. And then you know how to integrate this. You can just separate it and solve. U cube by 3, u raised to 5 by 5. So if I solve this further, this becomes u cube by 3. This becomes u raised to 5 by 5. Here you already have a minus sign. And then what is u? Put the value, that was cos, right? Yes, that is your final answer. If you want to multiply minus sign inside, you can do that. So you get cos raised to 5x by 5 minus cos raised to 3x by 3. Yeah, and that is your final answer. Clear? Simple? Now, let's talk about some important results. So if we have integration of f of g of x dx, that is nothing but integration of f of g of x dx by derivative of gx. See, in derivatives, what we used to do is, I'll give you a simple example. Suppose if I have cos of x square, right? So cos of x square, in that case, we find out, we consider that as cos x. And then x square, we take the derivative of that, right? And derivative of that is 2x. We multiply that. Here we don't multiply. We divide the derivative. There we used to multiply the derivative. Here we will divide the derivative, right? So this is integral. This is differentiation, g dash x, right? I'll give a simple example, sine 2x. I hope you remember, we solved this previously, but with more steps. Now let us do it orally. See, sine 2x. So integration of sine x is minus cos x. So integration of sine 2x is minus cos 2x. But this 2x, what is the derivative of 2x? You will divide it here. Derivative of 2x is 2. So divide by 2. So minus cos 2x by 2. Right? So this is like your g of x. The function is sine. G of x is your 2x. So g dash x you will divide. So this is what you get. I hope this part is clear to all of you. Simple. Let's continue. Now let us see how do we integrate sine raised to mx dx, cos raised to mx dx, right? So here we express sine raised to mx and cos raised to mx in terms of sine and cos and multiples of x by application of following trigonometric identities. So sine square x will be 1 by 2 1 minus cos 2x, right? Cos square x will be 1 by 2 1 plus cos 2x. This is how you replace it, and these formula we already know, right? Because we directly don't have the formula for integration of sine square x. So don't consider that as x square and then x cubed by 3. It doesn't happen like that, okay? You have to replace sine square x by 1 minus cos 2x, cos square x by 1 plus cos 2x. If you have sine 3x, that is 3 sine x minus 4 sine cube x. Or else if they give you like this, integration of 4 sine cube x, you can take it as 3 sine x minus sine 3x, right? Then you have this. Let's continue. So to integrate sine mx cos nx dx, sine mx, these are the different combinations basically. So the combinations you can get it anyhow. You'll get to know once we solve the problems based on it. Also, please make a note of all these formulae. This you have already studied in your 11th grade, isn't it? This we have already studied. We know that sine of a plus b plus sine of a minus b is 2 sine cos, that is 2 sine a cos b. Then sine minus sine is 2 cos sine. Cos plus cos is 2 cos cos. And cos minus cos is 2 sine sine. Right? Okay, but here the only difference is first you get a minus b and then you have a plus b. This you already know. Make a list of this. Let's continue with the problems. Okay. The first question says evaluate sine square dx, sine square x dx. So can we take this as x square and then take it as x cube by 3? Can we do that? That is sine cube x by 3. No, we cannot do that, right? So this needs to be converted. Converted to what? We know that sine square x is 1 minus cos 2x by 2. So this working is for your understanding. If you directly know the formula, do it. That is sine square x is 1 minus cos 2x by 2. So this becomes 1 minus cos 2x by 2. Now separate this 2 in the denominator. That is 1 by 2 minus cos 2x by 2. So this becomes, okay, you can take 1 by 2 outside and then separate it. So integration of 1 is x. Integration of cos 2x is sine 2x by 2 plus c. I hope this part is clear to all of you. Simple. Let's continue further. And then this is same, you can multiply 2 inside. Okay. The new question says evaluate tan square x dx. So tan square theta. We know that tan square theta is sec square theta minus 1. So tan square x will be sec square x minus 1. See, we don't have direct formula or direct integral of tan square x. That is why we need to convert it. Now you can separate it. Separate as in integration of sec square x or sec square theta minus 1. So this becomes, instead of theta, it should be x. This is x, right? Okay. So integration of sec square x is tan x. Integration of 1 is x plus c. That's it. Simple. So tan x minus x plus c. Now we have sine square 16x dx. Now this is sine square 16x dx. We know that sine square theta is 1 minus cos 2 theta by 2. So angle is double here. So here also the angle will be doubled. Angle will be doubled. Theta becomes 2 theta. So this becomes 1 minus cos 32x by 2 dx. So now this is 1 by 2 common, 1 minus cos 32x dx. So separate this, solve it further. Integration of 1 is x. Integration of cos 32x is sin 32x by 32. That is your final answer. If you want, you can multiply 2 inside. That becomes half x minus sin 32x by 64 plus c. Clear? Okay. Now let us see a new problem. It says sin 7x into cos 12x dx. Sin 7x into cos 12x dx. Right? Now we know the formula 2 sin cos, if you remember. 2 sin cos. I'm multiplying by 2, dividing by 2. And 2 sin cos is what? Sin plus sin. Correct? So 2 sin cos is sin plus sin. A plus b in one and a minus b in the other. Let us do that. A plus b, that is 7x plus 12x. A minus b, 7x minus 12x. I hope this part is clear. Now this becomes 19 and this becomes minus 5. Sine of minus theta. Recall, sine of minus theta is minus sine theta. So this becomes 19x and this becomes minus sine 5x. Now just you need to take the integration of this sine. Integration of sine is minus cos. And then divide by 19, there divide by 5. Simple. So what do we get? Here we are going to get minus cos 19x by 19 and this minus will become plus, right? Because the integration of sine is negative. And then multiply half inside. So this is what you get. Simple question, isn't it? Let's continue further. Now we have some special integrals. Now this, I won't say complicated, but make sure that you know all the formulae here, because if you are not thorough with the formulae, solving problems is going to become very difficult. Okay. So integration of 1 by x square minus a square dx is 1 by 2a log of x minus a by x plus a plus c. If you have a square minus x square, it becomes 1 by 2a log of a plus x by a minus x plus c. Then we have 1 by x square plus a square. X square plus a square and a square plus x square is the same thing. For this, I repeat again, a square plus x square plus a square, whatever combination you get doesn't matter. It is 1 by a tan inverse x by a plus c. And then if you have under root, that is 1 by under root x square minus a square, that is log of x plus square root of x square minus a square plus c. If you have a square minus x square, that is sine inverse of x by a plus c. And then here again, you have a square plus x square or you have x square plus a square, doesn't matter. In both the cases, you will have log of x plus x square plus a square under root plus c. So please make a note of all these formulae because we are going to have ample of problems based on this. Clear? Okay. Now, there are some important substitutions when we see these formats. So whenever you see this format, a square minus x square or under root a square minus x square, in that case, there is something that you need to substitute here. So we substitute x as a sin theta or x as a cos theta. That depends on the question. Whenever we have plus, we substitute x as a tan theta or a cot theta. And whenever we have this format, we substitute x as a sec theta or a cosec theta. So if you see, these are complementary. Sin and cos, tan and cot, sec and cosec. They are complementary angles basically. So let us try to understand this in detail. Now here we have 1 by x square minus a square, right? So x is what? X is the variable. A is what? A is the constant, isn't it? Let us see an example now. We're supposed to evaluate 1 by x square minus 16. So we need to make it in the format of a square. So 16 is square of what? 16 is the square of 4. So can I say this becomes integration 1 by x square minus 4 square, because 4 square is 16. So this further can be written as 1 by 2a. So a is what? A is 4. X becomes x only. It is going to be x only. It's not going to change, right? So this is 1 by 2 into 4 log of x minus 4 by x plus 4 plus c. I hope this part is clear to all of you. This becomes 1 by 8 log of mod of x minus 4 by x plus 4 plus c. Wherever you have a, you have put 4. That's it. Let's continue. Very simple. And this is the format. The constant comes first, then comes the variable, right? Slightly different. Constant comes first, then comes the variable. Let us see an example. See, constant is coming first, then is coming the variable. So 9 is what? 3 square, no? 9 is 3 square. Our a is 3. That is x square. So let us continue that. This becomes 1 by 2a. That is 1 by 2 into 3. Log of 3 plus x by 3 minus x plus c. So 1 by 6 log of 3 plus x plus by 3 minus x plus c. Simple. Okay. Now we have plus in the middle. Let us see an example. Integration of 1 by x square plus 9. So x square plus 9 is nothing but x square plus 9 is what? 3 square. Correct? Let us do that. So this becomes 1 by x square plus 3 square. A is 3. Put 3 here. That is your final answer. Have a look at this. So 1 by 3 tan inverse of x by 3 plus c. New format under root. So here you have a square root. Don't get confused between 1 by x square minus a square and 1 by under root x square minus a square. Both of them are different. 1 by under root x square minus a square and 1 by x square minus a square are different. So here you have 1 by under root x square minus 4. So this 4 is nothing but 2 square, right? 4 is 2 square. So we have 1 by under root x square minus 2 square. So wherever you have a, there you will put 2. So this becomes log of x plus x square minus 2 square. That is x square minus 4 plus c. I hope this part is clear to all of you. Simple. Okay. Let's continue further. Now this is 1 by under root of a square minus x square. This is 1 by under root of a square minus x square, which is equal to sine inverse x by a plus c, right? So here we are taking an example. Constant comes first, then comes the variable. So same thing, what will be a? A will be 4 here, isn't it? So a is 4, and then this becomes sine inverse x by a. So sine inverse x by 4 plus c. That's it. Now for plus, if you have a square plus x square or x square plus a square, doesn't matter, both of them are same. If you have 4 plus x square or you have x square plus 4, same thing. Put it in this. A is 2, right? Since a is 2, what are you going to get? 2 square here, rest remains the same according to the formula. That becomes 4. Nothing new. Clear? So this is the final answer. Okay. Now let us see some actual examples. So we have already studied the formulae as well as some basic problems on it. Now you need to identify the pattern. Once you identify the pattern and you know the formulae, the question becomes very simple. So here you have evaluate integral 1 by 7 minus 25x square. 1 by 7 minus 25x square, right? So this is like your a square minus x square, isn't it? The format is 1 by a square minus x square. So 7 can be written as 7 by 25, right? What I'm doing is I'm dividing by 25 here. So this becomes 7 by 25 minus x square and 1 by 25 taken outside. So this becomes your a and this becomes your x square. But again, we need to convert 7 by 25 in the form of square, which can be written as under root of 7 by 5 the whole square. See here. So what is A? A is nothing but under root 7 by 5. X remains as it is, doesn't make a difference. So this is nothing but 1 by 2a log of mod of a plus x by a minus x plus c. Put the values. So once you put the values, 1 by 2a, 1 by 25 is already there. 1 by 2a, 1 by 2 we have taken. This is a log of a plus x in the numerator, a minus x in the denominator plus c. Clear? And then you can solve this further, 5 ones are, 5 fives are. This is the final answer that you get. I hope this is clear to all of you. Very simple. Let's continue further. This is very simple now. Nothing much in that. Are you able to identify the format? It is 1 by x square minus a square. 1 by x square minus a square. X square is already there. But 5 is not a perfect square. Doesn't matter. We can write it as root 5 the whole square. Right? Let's write it as root 5 the whole square. X square minus a square. This is the formula as we already know. Instead of a, I'll put root 5. Let's do that. So here is a root 5. Here is a root 5. That's it. Clear? Simple. Let's continue. Now you see different types of integral. So the first type is 1 by ax square plus bx plus c. Basically, we have a quadratic polynomial in the denominator. This is a quadratic polynomial, isn't it? Ax square plus bx plus c. So what we do in that? We have 1 by 2x square plus 4x plus 18. Firstly, we can take 2 common. What will happen? If I take 2 common, 1 by 2 will come outside. This will become x square plus 2x plus 9. Now, picking the first two terms, we'll try to make a perfect square there. Try to make a perfect square. Either a plus b the whole square or a minus b the whole square. So can I say I need to add 1? Because x square plus 2x plus 1 is x plus 1 the whole square. Right? So convert the denominator in the form of x square minus a square or x square plus a square. So this x is nothing but that entire a plus b the whole square or a minus b the whole square. Don't worry, you'll get to know this. So see here, I'm adding 1, I'm subtracting 1, adding 1, subtracting 1. So this becomes x plus 1 the whole square. 9 minus 1 is 8. 8 becomes 2 root 2 the whole square. Now this is of the form 1 by x square plus a square. Right? And then you can solve that further, which is nothing but tan inverse x by a plus c, 1 by a tan inverse x by a plus c. So this becomes 1 by 2 was already there. 1 by a, our a itself was what? 2 root 2, tan inverse x by a. This is x. This is a plus c. Simple. Put the values, get the answer. Nothing new in that. Clear? Let's continue further. Now what if we have under root? Doesn't matter. Even if we have under root there, we're going to apply the same logic. See, evaluate 1 by under root of x square plus 2x plus 9. Again, we'll convert the denominator into this form or this form. Because it is plus, this form is better now. Again, I'll add 1. I'll subtract 1. Once I do that, this becomes x square plus 2x plus 1. That is nothing but x plus 1 the whole square. This becomes 2 root 2. But this time we have under root. Doesn't matter, we know the formula, right? So this will act like our x. This will act like our a. Let's continue. Formula we know. We know what is x. We know what is a. Put the values here. See, this is our x. Instead of x, we are putting this. This is our a. And if you square this, you are going to get 8. Right? We'll do that in the next step. See. This is x. This is x. And that's it. Simple. So instead of x, we have x plus 1. And instead of a, we had 2 root 2. We squared that and we got 8. Clear? Okay. Same thing again. under root of x square plus 2x plus 2. Again, what I can do is I can write down this 2 as 1 plus 1 or add 1, subtract 1. Same thing, whatever you are comfortable with, you can do that. So here it is. Okay, 2 is written as 1 plus 1. This becomes a perfect square, x plus 1 the whole square. This is 1, this becomes 1 square. So x plus 1 the whole square, 1 square. This is like your x. This is like your a. Clear? Let's continue. So here we can take this as t. We can directly also do it. Even if you don't want to take it as t, that's okay. So this becomes t square plus 1 square. So this is of the form 1 by under root x square plus a square, which is log of x plus square root of x square plus a square plus c. Put the values there. Here we have it in t, doesn't matter. Again, you need to replace this t at the end. What is t? T is x plus 1. This is x plus 1. This is x plus 1 the whole square. And this is 1 square, which is 1. So, and if you want, you can also expand this x square plus 2x plus 1. And then plus 1, that is x square plus 2x plus 2. You can do that. Okay, let's continue further. So here is a new example. 1 by 9 minus 4x square. Firstly, we don't want 4. We want only x square. So we will divide by 4. So this will become under root 9 by 4 minus x square. Let us see how does it look like. Dividing by 4. See, dividing by 4, dividing by 4. And then, what is the square root of 4? 2. That goes outside. Now this is of the form 1 by a square minus x square. What is a? 3 by 2. Because 3 by 2 square, right? So yes, just solve this further. This will become 1 by 2. Why 1 by 2? Because 1 by 2 is already there. Sine inverse x by a. X is what? X is x. What is a? A is 3 by 2. So 3 by 2, that is why 2 is going up. And that becomes 2x by 3 plus c. Simple problem. Very easy. Let's continue. So evaluate integration of 1 by 9 plus 4x square dx. Very simple. Again, we don't want 4. Well, divide by 4, multiply by 4. Let us do that. Let's divide by 4, multiply by 4. Here I am dividing by 4 and outside I am multiplying by 4 here. Now observe this pattern. This is 3 by 2 whole square plus x square. That is a square plus x square. So this becomes 1 by 4 as it is, multiplied by 2 by 3 into tan inverse of x by a plus c, that is 2x by 3 plus c. So this is of the form, and then you can continue solving this. That becomes 1 by 6 tan inverse 2x by 3 plus c. That's it. Very simple. Okay, let's continue. Now this is interesting because you have e raised to x and then you have e raised to 2x and here also you have e raised to x. So definitely some form of substitution is needed in this question for sure. But what type of substitution is needed? We need to check that. Now if I consider e raised to x as t or u, then the numerator e raised to x dx becomes du and e raised to x is u. So I get a quadratic in the denominator inside the square root. See, if you see, here I have du and in the denominator I have under root 5 minus 4u minus u square. Correct? Now again this quadratic needs to be converted in the form of x square minus a square under root of x square minus a square or under root of x square plus a square, isn't it? Either of the two forms. So let us try to do that. Let us try to convert this into under root x square minus a square or x square plus a square. But definitely we have minus, so we are going to use this. Now see, u square is coming later. That's why the variable part comes later, constant comes first. So what I'm doing is, here I'm adding 4 and subtracting 4. Adding 4 and subtracting 4. So if I add 4, I get 9. If I subtract 4, I have this part. I can take minus sign common, and this becomes u plus 2 the whole square. So this is like my a, and this is like my x now. A and x. And once you have your a and x, you can solve it further very easily, isn't it? So this becomes sine inverse x by a plus c. But this will be your x, and this will be your a plus c. Simple. Let's continue. And obviously, at the end, please don't forget, you're also supposed to replace what you assumed. You assumed u as e raised to x. So replace that. Now let us see a new example. It says 1 by integration of 1 by x square plus 4x plus 8. Now we have x square plus 4x. 8 can be written as 4 plus 4, isn't it? This 8 you can write it as 4 plus 4. Now this is the perfect square. That is x plus 2 the whole square. Let us do that. So this is x plus 2 the whole square plus this is 2 square. So this is like your 1 by x square plus a square. 1 by x square plus a square. We know the formula. Integration of 1 by x square plus a square dx is 1 by a tan inverse of x by a plus c. So that is 1 by 2 tan inverse of x by 2 plus c. That's it. And that is your final answer. Wherever you have a, that is 2. And whenever you have x, that is x plus 2. Let's continue further. Evaluate. This is 1. 1 by 5 minus 8x minus x square. So we have 5 minus 8x minus x square. So again what you can do is, you need to add and subtract something, right? So what I'm doing is I'm adding 16 and I'm subtracting 16. Why are we doing that? Because see, whenever you have the format of a plus b the whole square or a square, a minus b the whole square, the middle term is 8, right? That is 2 into a into b. That is 2 into 1 into 4. So you need 4 square, right? So 4 square is 16. That is why we have added and subtracted 16. Once you do that, 5 plus 16 gives me 21. From here, you can take minus sign common, and inside that, all the minus signs are common there. That becomes x plus 4 the whole square. So this is under root 21 the whole square minus x plus 4 the whole square. Clear? So what is your a? Your a is under root 21. What is your x? Your x is x plus 4 the whole square. Clear? Let's continue. Put the values, get the answer. Once you put the values, this is what you get. Simple. Alright, then let us continue now. So we have seen integration by substitution. Now we will see integration by partial fractions. Okay. Now, whenever you have non-repeated linear factors, when the denominator has distinct linear factors like x minus a, x minus b, you can also have the format of linear factors x plus a, x minus b. That completely depends on the question. Linear factors in the denominator. What is the meaning of linear? Linear means the degree is 1. So if you observe the variable x, what is the highest power of variable x? 1, 1. Something like this. What we do is, we assume this as equal to a by x minus a plus b by x minus b. We start like this. So basically, partial fractions, we are breaking it down into partial fractions. We find out this capital A and capital B. We do that first. Let us see an example. Now observe this part. We have x square minus 2x plus 3. See, if this was 1, then it was very simple. Adding 1 on both the sides. not both the sides in fact, adding 1 and subtracting 1 in the denominator basically. So if I add 1 and subtract 1 in the denominator, that becomes x square minus 2x plus 1 plus 3 minus 1. That is x minus 1 the whole square plus root 2 square. But here we already have a function in the numerator. So we cannot use our previous method. And that is why we need to use partial fractions. This would be a lot easier if we would rewrite it as two separate terms. So what we will do is, firstly we will factorize this. That is x minus 3, x plus 1, and that is further equal to now a by x minus 3 plus b by x plus 1. Now we'll solve this. X plus 1 goes here, x minus 3 goes here. This will get cancelled. And then you equate it now. So 5x minus 3 is equal to a multiplied by x plus 1 plus b multiplied by x minus 3. Now multiply a inside. So you get ax plus a plus bx minus 3b. Now you take the x terms together. Take the x terms together. So ax plus bx plus a minus 3b. Ax plus bx plus a minus 3b. X common, a plus b, and this is a minus 3b. So a plus b is 5 and a minus 3b is minus 3, right? So a plus b is 5, a minus 3b is minus 3. So from here, if I solve both the equations simultaneously, this will get cancelled. B plus 3b is 4b. 4b is equal to 8. And then the value of b will be 2. And then the value of a will be 3. So once you get the value of a and b, you substitute it there. Here. This is the value of a, this is the value of b. Now this is equal to this. Take the separate integrals and solve it now. This is very simple. This is 1 by x, which is nothing but log x. This is 1 by x, which is nothing but log x. That's it. That is how you solve in partial fractions, right? Okay, let us have a look at one more example. Same thing. We have a function. We have linear x minus a, x minus b. As I said, it can be x minus a, x plus b also. Depends, minus plus doesn't matter. So here this will be equal to a upon x minus 1 plus b upon x plus 2. Cross multiply. So 5x plus 4 will be equal to a into x plus 2 plus b into x minus 1. Solve it further, multiply a inside. You can do that. There is one more way. You can randomly substitute. That's your choice. Let's substitute x as 1. If x is 1, what do we get? We get the value of a as 3. Why we have taken x as 1, you know? Because this b will be eliminated. If I put x as 1 here, this part will become 0, no? Now to get the value of b, what you do is put x as minus 2. So that a will become 0. Okay. See, I'm putting x as minus 2. This becomes 0. This is minus 2 minus 1 minus 3. X as minus 2. Solve it. You get the value of b as 2. I hope this part is clear to all of you. You got the value of a, you got the value of b, plus b by x plus 2. A by x minus 1 plus b by x plus 2. The value of a was 3. The value of b was 2. We have just put the values here. I hope this part is clear and simple. So we get 3 log of x minus 1 plus 2 log of x plus 2 plus c, and that is your final answer. I hope all of you are understanding this. Let's further continue that. Now understand, we have repeated linear factors. When the denominator has repeated linear factors like x minus 2 the whole square, x minus 5 the whole cube, we express the function as a1 by x minus a plus a2 by x minus a the whole square. Because see, if I take the LCM is going to be like this only, x minus a raised to n. Doesn't matter, no? If I have x cube, I can take a1 by x minus a plus a2 by x minus a the whole square, and then a3 by x minus a the whole cube, because the LCM is cube 3. Let us see an example. So here we have 2, right? The power, see the power basically. So we'll write down a by x plus 2 plus b by x plus 2 the whole square. See, a by x plus 2 plus b by x plus 2 the whole square. If it was cube, we'll write down plus c by x plus 2 the whole cube. Now same thing, cross multiply, right? And then this will get cancelled. So 6x plus 7. Now if you want b, you can put a as minus 2. The choice is yours. You can do it in anyhow. Make sure that you get the values of a and b. Getting the values of a and b is important here. So here I am multiplying inside. The value of a is 6, right? Because we are just comparing. See, we are comparing what? Ax with 6x. So a is 6, and then 2a plus b is 7. Put a as 6 there. Put a as 6. So 12 plus b is equal to 7. So b is equal to minus 5. Once you get the values of a and b, now it becomes very simple. This is a by x plus 2, and then we have b by x plus 2 the whole square. This we know, this will become 6 into log of x plus 2 plus this is x plus 2 the whole square. So can I say this is nothing but x plus 2 raised to minus 2, and this minus sign further becomes plus. Clear and simple. Let's continue further. Now third type is, we have some quadratic which are irreducible factors when the denominator has irreducible quadratic basically. Let us see how to solve those. So in this case, we write down px as ax plus b. This is very simple. See, now this is x plus 1 and this is x square plus 2x plus 5. Obviously you cannot factorize that, it is irreducible. So what we do is, we are going to write this as a by x plus 1 and then bx plus c by x square plus 2x plus 5. Now you cross multiply, right? So this is what you get. Once you get this, now bx will be multiplied with x plus 1, c will be multiplied with x plus 1. Now we have 1, 1. Now if I put x as minus 1, b will get cancelled, c will get cancelled, I will get a. Let us do that. That is one of the ways. Second way is, which I mentioned, put x as minus 1. Second way is you keep on multiplying the brackets inside. Doesn't matter, keep on multiplying further. And then compare the coefficients. So this a plus b is 1, 2a plus b plus c is 3, and 5a plus c is 5. Right? And then you solve this, put it here. We are substituting b is equal to 1 minus a. This b is equal to 1 minus a over here. And then we will put a plus c is equal to 2 into 5a plus c. You get the value of a here. The value of a will be 3 by 4, isn't it? Once you get the value of a, you can solve further. You get the value of b. Value of b is 1 minus 3 by 4. That is 1 by 4. And then get the value of c. C is nothing but 2 minus 3 by 4, which is 5 by 4. You got a, you got b, you got c. All three values. Now you know where to put that. You need to put it over here. The value of a you will put here, and bx plus c. b is 1 by 4, c is 5 by 4. Solve it further. So this is 3 by 4 into x plus 1. And this is x plus 5 by 4 into x square plus 2x plus 5. Right? Now you solve this further and then you can take 3 by 4 outside. Here you can take 1 by 4 outside. And if you observe, here I'm multiplying by 2, dividing by 2. That becomes 2x plus 10. Why am I doing that? I'm doing this because here if you notice very carefully, observe this part. You can further write it as 2x plus 2 plus 8. We separated this, 8 gets cancelled. This is 3 by 4 times x plus 1. This is 2x plus 2 by as it is. Now this, you know how to solve, right? Separate the integrals. This is tan inverse x by a plus c. This you can solve. This is log of x plus 1. And then plus c, that is your final answer. Slightly, it can be extending, but make sure that you're solving it correctly. Once you know the procedure, if you have a linear factor here, and then you have a quadratic here, right, which is non-reducible, put it as a by linear plus bx plus c by quadratic, and then get the answer. I hope this part is clear to all of you. So if the degree of the numerator is higher than the degree of the denominator, we'll use long division first. We'll do long division. This is the quotient as you know. Then you get x minus 3 by x minus 3 into x plus 1. You can solve that further. X minus 3 gets cancelled. This becomes integration 2x and then integration 1 by x plus 1, which is log of x plus 1. That's it. And this becomes x square by 2. This is the final answer. Simple? Okay. Let's continue. Now let's talk about integration by parts. So integration by parts is a technique used to evaluate integrals where the integrand is a product of two functions. So the formula for integration by parts is given by integration of u into v dx. That is, here also you can talk about the product, that is UV rule. You have studied about the UV rule in the chapter of differentiation, right? Derivative of u into v. U derivative of v plus v derivative of u, right? This is slightly different. This is u integral v minus integral of derivative of u integral of v. U integral v minus derivative u integral v dx. So this is what you need to remember to solve problems. So when we have product of two different functions basically. So we select this u of x and v of x. And this is Liet rule. What is Liet rule? First we take logarithmic, then inverse, then algebraic, then trigonometric, and then finally exponential. I'll give you a simple example. If you have, say, sin x into log x. Sin x is trigonometric, log x is logarithmic, sin x into log x, two different functions. But according to Liet rule, you write down log x into sin x. If you have sin x into log x, you write down log x into sin x. I'll give you one more example. Say you have x cube into sin inverse of x. X cube into sin inverse x. X cube is algebraic, sin inverse x is inverse. Write down inverse first, then write down the algebraic, that is sin inverse x into x cube. So logarithmic, inverse, algebraic, trigonometric, and then exponential. This is Liet rule. Okay, let's continue. So let us see an example. Evaluate x into sin x dx. So according to Liet, L-I-A-T-E, okay, this is algebraic and this is trigonometric. It's already in the order, algebraic, trigonometric. So no need to change the order, right? This is u, this is v, uv. So u integration of v minus integration of derivative of u into integral of v dx, right? So u integral v minus derivative of u, obviously integration is outside, and then integral v. Put it carefully. So u is x, integration of v minus integration of derivative of u, derivative of x, because u is x, integration of v dx. Now this is very simple. Just find this out. So we get minus x cos x minus integration of derivative of x is 1. So only integration of sin x, which is minus cos x dx. Further, this becomes minus x cos x minus minus will become plus, and then this will become integration of cos x, which is sin x. So you get minus x cos x plus sin x plus c, right? Now let us see an example. Evaluate log x dx. Now you'll say only one function is there, log x. No, but in such cases, you can use log x into 1 dx. Log x into 1 dx, right? So this is your u and this is your v. Let us solve that. Log x is u, 1 is v. So u, integration of v, that is integration of 1 dx, minus minus integration of d by dx of log x, integration of 1 into dx, right? So that is x log x, this is x log x minus, this becomes d by dx of log x is 1 by x, this is 1 dx, x gets cancelled. So that becomes integration of 1, which is nothing but x. So x log x minus x plus c. This is minus x log x minus x plus c. Simple. We have x raised to 4 into log x dx. So Liet rule, log always comes first, then polynomial, right? Okay, so this is u, and that is v, correct? So u integral v minus integral of derivative of u into integral of v dx. U is log x, v is x raised to 4, u is again log x, v is x raised to 4, log x remains as it is, this becomes x raised to 5 by 5, log x becomes 1 by x, this becomes x raised to 5 by 5, this gets cancelled, you get x raised to 4, again integration of x raised to 4 needs to be done here, so integration of x raised to 4 will be x raised to 5 by 5, so denominator becomes 25, we are not doing anything with this, this remains as it is, right? Only this part was supposed to be solved, and then this is the final answer, right? So we have studied how to solve basic problems, then we have studied how to solve problems based on substitution, how to solve problems based on partial fractions, how to solve problems based on integration by parts, the UV rule, the product rule as well. So I hope you enjoyed the session on indefinite integrals. We're also going to study definite integrals in the next session. So stay tuned with Top Scholars.